Hello everyone. Welcome to the Horizons21 Investor and Analyst Day. I'm Andrew Bender, Chief Technology Officer of DZS. Today I want to give you an update on our Market Scouting Report, where we'll be talking about the market for DZS, our technology vision, and how that applies to our solutions. If we haven't talked before, I've joined DZS recently in the last year to lead our technology team and initiatives. I come to DZS from a company called VMware that is well known in the software and virtualization space, specifically working with carriers and service providers in their journey to create a software-defined network. I also had a similar role at Hewlett Packard Enterprise, working in the infrastructure layer of that software-defined network, as well as a number of startup and established companies like NEC, Ribbon Communications, and others. But I am proud to be a part of DZS now, working alongside a great team to drive all of our technology initiatives in the new One DZS organization we are creating together. For the last few weeks, I've been in Seoul, South Korea, working with our R&D teams here as we formulate the plans to roll out some of the initiatives that I will be talking to you about today. So, I'd like to share some details about what we've been working on. I'll start today's discussion with a few words on our investment strategy. Over the last several months that I've been with DZS, we've made great strides in communicating where we are going as a company to the market and to customers. Our strategy is composed of 4 key technology pillars which have been the focus of our investments. The first of these is mobile transport. This is the technology that supports the radio access network, providing connectivity inside of mobile networks. We'll talk more about that through the session today. Broadband access and optical broadband has been a core business for DZS throughout the history of the company and remains so today. Connected premises is the category we have created to define how users, customers, and enterprises get access to the network, leveraging our complementary platforms for broadband access and mobile transport. And the last category is the newest one we have added, which I'm very excited to talk about, and this is the orchestration and analytics area. Our target markets and customers for the company are service providers globally. This is our main channel to market and customer base for the products that we create across the 4 pillars that I talked about. We have over 1,000 customers in over 100 countries and over 750 employees, with more than 50% of those in research and development. So we wake up every day thinking about service providers, the world's most admired carriers, and how to help them do business, just as you heard from Charlie today. Our company status is also an important element of our strategy. We are, and will continue to be, a trusted supplier with a strong financial and business outlook, assuring that our service provider customers can have continuity of supply and ongoing access to the technology and solutions that come from the 4 focus pillars we talked about. A key change that we have made in how we talk about DZS and what we do is our solution focus. The 4 technology pillars do correspond to product areas for us at DZS, but they actually entail solutions as well. What does that mean? From our perspective, solutions potentially entail multiple products, many of which can come from DZS and the technology pillars that we have talked about. But solutions also entail partnerships. We have a network of important solutions partners, technology partners, go-to-market partners that all come together to help us create the overall solutions for optical broadband, for mobile transport, for connected premises, and for DZS Cloud as well. So I will step through each one of these solution areas briefly. First is our Kronos mobile transport portfolio. This is a solution set, as suggested by the illustration, where we offer technology connecting the elements of wireless networks into the core, allowing the services and applications that come from mobile handsets and connected devices to connect to the rest of the world and the internet. Supporting this architecture, we have a range of specialized products and associated software technologies that make this possible. This application is something that we're excited to talk about because it's a high growth area for the company. We've taken a number of steps recently in product announcements, platform designs, and new capabilities that we bring to the network specifically to address this application domain. I'll explain a little bit more about this scenario coming up. The next solution for us to talk about is the Velocity Broadband Access and Optical Broadband Portfolio. This is how we provide wire, or nowadays optical fiber, connected broadband access and internet service to customers throughout the world. This is a solution set that makes use of so-called passive optical network technology, which allows a shared fiber medium to provide high-speed internet connectivity at optical speeds to multiple customers in a very affordable way. Recently, we've seen a progression of this technology from 1 gigabit to 10 gigabit and soon beyond these levels. The drivers for this technology progression are key applications like streaming video, interactive HD video communication, real-time gaming, supporting connected devices in the home, and so forth. We also see this technology simultaneously supporting high-speed access for businesses and enterprises. Our Helix portfolio represents the connected premises solutions that we have at DZS. This solution includes equipment that goes into subscribers' homes, providing connections to that optical broadband network, or in some cases, copper-based XDSL or G-Fast networks where fiber is not yet available. The Helix solution also extends inside the home, providing high-speed wireless connectivity with technologies you'll hear about like mesh Wi-Fi, Wi-Fi 6, and Wi-Fi 6E. This solution is supported by a collection of software services and value-added capabilities that make all of these systems and devices work together. The next and last solution category is a new one that comes to us through the acquisition of Rift. You'll hear many members of our leadership team in Horizons talk about our acquisition of Rift and the technology it's brought into the company. The category of solutions, including DZS technology and the network of partners making up the ecosystem for cloud-based management and delivery of applications, is what we call DZS Cloud. I'll explain how this works in the context of a mobile network as an example coming up. To set the stage for DZS Cloud and the technology solutions that we have in the Kronos portfolio, I want to talk a bit about the evolution of wireless access networks. You probably heard about 5G technology as an important emerging area where changes are occurring in the network for customers and service providers on a global basis. In order to understand the architecture of 5G networks and how they're relevant to DZS, it makes sense for us to start from the point of what a typical network looked like before 5G and before some of the changes that we're enabling in this new architecture. What you see here is a schematic illustration of how user equipment, think of a smartphone or a wireless network connected device, would interface to the wireless network. The wireless network includes something we call a radio unit that's often placed on a tower site or as part of the outdoor cell site equipment that's familiar to many people. These tower-mounted antennas and radio units are actually supported by a cascade of equipment. So all of these elements shown in the traditional base station site, from the radio to the baseband unit, cell site router to the transport equipment, work together to take the information that comes from the user equipment over the air and connect it to the core network, which in turn delivers that traffic to the internet. One of the realities of today's existing wireless network is that many of the pieces of network equipment, network elements, and functions found at one of these traditional base station sites are all part of closed proprietary system. This means that the components shown at this site must come from the same vendor and they must be interconnected together. In many cases, this eliminates the possibility of vendor choice and, frankly, access to new technology and innovation in networks that are built this way. With this approach, one thing is certain. We know that all these systems work together because they are all supported by and installed by a single vendor. However, what many operators are telling us is they need to be able to change their networks, to expand, to grow, to adapt, and provide new services, keeping pace with the speed of progress in the internet, web applications, and the changing appetite of customers. Having closed proprietary systems does not give service providers the ingredients they need to be successful in this context. So now when we think about 5G and how these networks will be built, you will see the architecture of the network has changed. In this illustration, you see an expanded view of what happens between the user equipment, such as a mobile handset, or perhaps a 4G, 5G wireless router, fixed wireless access device, and the other end, where we see the public internet. In this picture, you will still see a radio system or radio unit that's on the tower, which could be 4G, 5G, or both. But you now also see a network of other devices, including a packet-based front haul gateway, a baseband unit, which may now be virtualized, or other devices that take over for the baseband unit that are distributed into the network, like centralized units and distributed units, or CUs and DUs. Routers are still present, and there are also backhaul transport functions, transport aggregation devices as well. These may be at the cell site or again distributed into other locations. Many of these devices, the ones highlighted, are made by DZS. These devices that we make are designed to support the new interface types and technologies that are required for 5G wireless networks. But just as importantly, these devices are open, meaning they can coexist with other elements shown in gray here that might not be provided by DZS, and therefore can be part of an end-to-end service architecture that is interoperable, that is scalable, and that is multi-vendor in nature. There's a key concept of virtualization you will hear us talk about in the context of 5G networks, and I'll explain what this means. For the network pictures you saw prior to 5G, almost all of the network elements that provide service were physical network functions. In other words, hardware devices, like some of those made by DZS, with embedded hardware to perform all the operations that are necessary to make a 4G network function. But in the 5G network, there's also another choice. More and more, we are seeing the functions provided in the network becoming pieces of software. These software-based functions will be distributed throughout the network, either in the core, closer to the edge, and alongside of physical network functions. Examples of these software-defined or virtual network functions include the packet core or 5G core, and radio access network functions such as a virtualized baseband unit. And for networks aligned with O-RAN Alliance or Open RAN standards, we have CU or DU functions. Each of these are software-based functions replacing some of those hardware functions that used to exist as physical network functions. The virtual network functions we talked about live alongside of and coexist with physical network functions that are necessary to provide connectivity, transport, routing functions, and traffic management between all of these software applications. So, in 5G networks, both software-defined or virtual network functions and physical network functions are both required in tandem for this network to be realized. Through the introduction of DZS Cloud, we have a uniform framework that understands the virtualized network functions, or sometimes you'll hear us describe them as containerized network functions, shown in gray here, as well as the physical network functions, shown in blue. As operators look to create a software-defined and software-controlled network that can be dynamically configured, provisioned, upgraded, or have applications deployed without manual intervention, truck rolls, or site visits, it is necessary to have an overall control framework that understands these virtualized or software-defined network functions, as well as the physical network functions. That's what DZS Cloud Service Orchestration does for us, and you'll hear Miguel share more important details about this approach. One of the key reasons for this approach of creating a unifying software-defined control system to orchestrate and automate the deployment of 5G networking functions is to support a concept called network slicing. So taking that same network we just discussed, an operator might wish to deploy a network that serves many different classes of users or many different applications, all of which have different parameters in terms of what types of performance they require, what type of capabilities they have, or what quantity of resources are to be used in a given network. In some of these cases, network functions are going to be dedicated like radio units, perhaps. Others may be shared like transport equipment. So if you're deploying a service to support Internet of Things with a specialized network of connected or intelligent devices for telemetry or remote control applications, you might have unique requirements for the network that are more driven by a need for a large number of devices and scale, and less about extreme bandwidth that might be required for streaming video applications. Likewise, an operator might have a service for enterprise customers, each having specific security or industry vertical requirements for their wireless network. For example, these customers or applications may be associated with private segments of dedicated spectrum to operate their businesses in a 5G connected way, but operators wish to be able to share the same infrastructure that includes both the virtualized network functions and physical network functions to provide these services. Of course, for the core customers of a smartphone or fixed wireless access service, now using the broadband internet capabilities that are available with 5G, may have their own slice and resource partition as well. Each one of these slices represents a logical partition of the network enabled by an orchestration system, such as DZS Cloud, that can manage the resource assignment and the partitioning of the network to allow network slicing to occur. You'll hear in our discussions today more about customers using DZS Cloud and technology for network slicing to enable services like those shown here. Now, taking a look at key customers who are using DZS mobile transport technology for 4G and 5G services. A key example is a company called Rakuten Mobile in Japan. The technology we're talking about here is again the virtualized and software-defined open way of providing 5G networks. And Rakuten is one of the first end-to-end deployments of that technology at scale. At DZS, we're providing network equipment and solutions through our Kronos portfolio specifically to support this architecture. However, Rakuten is not the first mobile operator that we've done business with at DZS on a large scale. Many of the other operators in Asia have been the first movers or leaders in the deployment of 5G services. Operators like LGU+, SK Broadband, and KT in Korea are using the mobile transport technology of our Kronos portfolio. This includes use cases you will hear us refer to as front haul, mid haul, and back haul. Collectively, we call these functions X-haul, and they represent the range of mobile transport applications we support with the DZS portfolio. In addition to mobile transport, broadband access and optical broadband remains a key part of what we do at DZS, and in fact, the relevance of this is growing with time. I'll talk a little bit more about that here in a moment. Here again, you see our illustration of the network spanning from the end-user equipment, the connected premises type devices like Wi-Fi 6 enabled CPE, mesh Wi-Fi devices, optical network terminals, or ONTs, that are all connecting to the optical broadband service using passive optical network technology, or active Ethernet technology, or in some cases using XDSL or GFast technology. These in turn connect to the network with a collection of devices that aggregate traffic, perhaps in a remote cabinet, a central office, or edge data center, providing connectivity between the end devices and a network core or the public internet. As time goes on, we've introduced new technology to support that progression from XDSL to 1 gigabit services to 10 gigabit services and beyond. That in turn drives capacity needs towards the center of the network at the 10, 25, 50, and 100 gigabit level. This is the kind of technology our progressive service provider customers rely upon to provide next-gen services and broadband access. This includes customers like Consolidated Communications, who you'll hear more from today, and also KCOM, Etisalat, and once again, U+. One key concept I want to take a few moments to talk about is how mobile 5G network deployments are driving the growth of the fiber network. This leads to an opportunity we describe as convergence. A few moments ago, I talked about how the 5G network is driving multiple changes in how and where it is deployed, what network functions are provided. This technology, in turn, requires optical fiber capabilities farther at the edge of the network and with a greater capacity, so we see a lot of concurrent upgrades of fiber networks with the deployment of 5G. Even traditional fixed network service provider customers of DZS may provide optical services to a business partner or wholesale customer who in turn is a mobile operator and needs specialized transport functions or needs access to these new edge locations where historically there has not been fiber, and passive optical networks can be an attractive solution here. You will also hear us talk about a recent acquisition of a company called Uptillion, providing specialized 100, 200, and 400 gigabit coherent optics technology used in DWDM, or dense wavelength division multiplexing optical networks. This is technology which was traditionally found in the backbone or the core of the network that allows us to dramatically increase the capacity of the fiber network by using different wavelengths or colors of light, allowing traffic from multiple services to coexist in the same optical network and even the same optical fiber. This leads to a picture similar to the one that we've been showing here of an intelligent and converged access network where we see a common infrastructure that can be used for both broadband access, optical broadband, and XDSL services, shown at the top of the diagram, along with the mobile transport application we talked about at the bottom of this diagram and its various elements. In many cases, both of these may share the same optical paths and may share the same kind of passive optical network technology to provide connectivity to small cells, Wi-Fi access points, or even wireless base stations to enable these services. Our vision is these technologies and networks together would be controlled by DZS Cloud and our associated offerings there. One of the other technology innovations that we've been working on is a unified platform software specifically to serve this convergence need. As these networks come together, mobile and fixed, we find there's a need to support mobile-specific features and capabilities in optical platforms or fixed network devices that previously did not have such a need. So this has driven an initiative that we call Sdnos. Sdnos is a software-defined network operating system, or NOS platform, that will run on the physical devices that we deploy in the network. The key concept here is state-of-the-art technology that is a modern, open-source inspired environment based on Linux. This allows us to innovate at the speed of the internet, but brings along an extensive and field-proven set of layer 0, 1, 2, and 3 features that are necessary to piece together the 5G mobile networks of tomorrow, as well as the high-speed 10 gigabit plus class optical broadband wireline networks that are out there. Sdnos will have a flexible architecture with intrinsic support for virtualization. Remember the importance of virtualization I described in the mobile network for the realization of 5G. We also see a similar trend for virtualization, distribution, and disaggregation of those same kinds of functions and network elements in the broadband network and the fixed network as well. So this is one of the reasons why we think it's important to have a unified set of platform capabilities and features to serve the network, whether it's 5G, 10G, or beyond going forward at DZS. Likewise, it's important for us to have a complete solution for the software-defined orchestration and automation of both the wireline and wireless networks. I talked before about DZS Cloud, the team and the technology that's come to us from the acquisition of Rift. The DZS Cloud team has developed a service orchestration platform that we call DZS Cloud Service Orchestrator, which understands the private, public, and hybrid cloud infrastructure where applications and software functions, like virtualized network functions, are deployed. It can also interact with and deploy those applications themselves. These are the kinds of services and functions that come to us from partners like Mavenir, Altiostar, Affirmed, Ribbon, and a list of many others. As we see increasing demand for operators to innovate and make their systems flexible, we'll also see software applications and network functions being deployed, being changed dynamically, redeployed, and moved throughout the network. Service orchestration is one of the ways that we accomplish this goal. Building on top of this platform, we have two exciting new initiatives that the DZS Cloud team will be helping us drive over the next year and beyond. This includes the network domain orchestration capability that we're working on, which will use SDN, software-defined networking technology, to address the physical network platforms that we provide at DZS, but in a dynamic and software-defined way so they can be as flexible and as adaptable as the virtualized network functions that they interconnect with. We're also creating an analytics and data management framework to support DZS Cloud. This means physical network functions as well as virtual network functions will make use of a modern framework inspired by web-scale applications and services in the Internet to collect all of the data. This will allow operators to have visualization and predictive analytics of the network using AI and machine learning type technology to understand and automatically operate the network. This, we believe, is really where operators are looking to go, to multiply the effectiveness and efficiency with which they operate this network, and to do so in an automated way. These three pieces, DZS Cloud Service Orchestrator, the Network Domain Orchestrator, and the Analytics and Data Management Framework offerings that we create as DZS Cloud, will all come together to make this possible. The last idea I want to leave you with is the degree to which we as DZS are embracing open networks. An important concept is that the 5G and 10G networks of today and tomorrow will depend on open standards and interfaces between various network elements and between various vendors. We at DZS are committed to support these architectures, and we're working with industry groups and standards organizations like the O-RAN Alliance, the Telecom Infra Project, Broadband Forum, Metro Ethernet Forum, ETSI, TM Forum, Open ROADM, and most recently the 25GS-PON MSA group to bring about these new technologies and increase the capabilities of the network, but also to do so in an open and interoperable way, capitalizing on all the technology innovations that the Internet has brought to us. With that, I thank you for joining us today.